Prescription drugs in water. The topics that will be discussed in this presentation are how pharmaceuticals get into our drinking water, the effect on us, the effect they have on animals, the effect on the environment, how the problem can be fixed, and how to prevent pharmaceuticals from getting into our water supply. In Canada, we are very fortunate to have filtered, clean drinking water, but how clean is it really? Recently, there has been increased levels of prescription drugs in our drinking water due to the aging and growing population. This increase has been discovered by the modernization of technology. How pharmaceuticals get into our drinking water. Unused drugs are being flushed down toilets and drains and ending up in lakes, rivers, and streams. Because our bodies can only metabolize a small percentage of most drugs we swallow, the remainder is excreted in urine, feces, or sweat, where it ends up in waste. Medications in the form of creams and lotions are becoming more popular, and those that aren't absorbed into our skin are rinsed off, further contributing to the pollution. Because opioid painkillers are allowed to be flushed, nursing home staff have been known to flush down medications other than opioids mistakenly from patients who have died or been moved to another facility. Agriculture also contributes to the problem because animal waste is filled with hormones and antibiotics, fed to them and injected to them by farmers, which leak into our waterways. The effect pharmaceuticals have on us. Currently, there are no known long-term effects because it's too early to tell. Some of the prescription drugs found in drinking water include painkillers, blood thinner, hormones, chemotherapy drugs, and even cocaine. In February of 2014, Environment Canada told the Senate committee hearing that more than 165 pharmaceuticals were found in our drinking water. Water treatment facilities don't filter drinking water from these drugs, and there are no standards for filtration of them yet. The World Health Organization states that we are exposed to trace concentrations of pharmaceuticals found in drinking water, but it's more than 1,000 times below the lowest clinically active dosage. 3 case studies they consulted show that it is extremely unlikely to have risks from exposure to trace levels of pharmaceuticals in drinking water. According to Citizens Campaign for the Environment, the effects of constant low concentration of prescription drugs on ecosystems and humans are unknown, although possible health concerns include hormone disruption, antibiotic resistance, and synergetic effects. How it affects animals. There has been a much more evident effect on wildlife than there has been on us. The pollution of prescription drugs into water has especially been affecting aquatic life such as fish. Estrogen sources including birth control pills, postmenopausal hormone treatments, and natural estrogen that women excrete have been causing male fish to become more feminine and raising the female fish population. There have even been intersex fish found on the Potomac River who have both male and female sex characteristics. These fish develop eggs in their testes, which has put some species in danger. These intersex fish have mostly been found downstream from water treatment sewage plants, as well as there have been some antidepressant medications found in these fish's brains, who live downstream from the sewage plants. Fish in New York's Jamaica Bay are also experiencing feminization, where the ratio of female to male winter flounder is up 10-1. The effect on the environment. Recent studies have detected low levels of a wide range of pharmaceutical drugs in soils, surface waters, and groundwater. Some ways pharmaceuticals enter the environment include manufacturing drugs that create residue and enter surface waters, human excretion into the sewage system, veterinary medicines used to treat pastured animals are excreted into soil or surface water and enter the environment by manure as fertilizers. And once released into the environment, these pharmaceuticals will be transported and distributed to air, water, soil, or sediment. Long-term, low-level exposure to pharmaceuticals results in effects on insect physiology and behavior, dung decomposition, inhibition or stimulation of growth in aquatic plant and algae species, development on antibacterial resistance in soil microbes. Antibiotics from human and veterinary use affect soil microbes and algae. How to fix the problem. The issue with the removal of drugs from water is that water treatment processes are not designed to remove pharmaceuticals, though they do remove a considerable amount. The physical properties of each drug is taken into consideration in the removal process, hence why not all the drugs can be removed completely. Some treatment facilities might be able to remove the drugs from the water entirely, but others are not as advanced or efficient, leaving a higher percent of pharmaceuticals behind. Finally, how can we prevent pharmaceutical drugs from entering our water? First, we must reduce the amount of purchases made in bulk because the price might be less, but unused medication could end up in the water. Secondly, use drug take-back programs and return unused medication. Third, don't flush unused medications down the toilet or pour them down the drain. And fourth, advocate for it to be mandatory for water treatment facilities to filter drinking water and for there to be standards for the amount of water that must be filtered. Thank you for listening to our presentation on prescription drugs and water.